Namaste students. In the last class we were studying about the cofactors of a matrix. You have understood what is the meaning of minors and cofactors. Minor is defined as the lower order determinant which is got by the deleting the row and the column in which the element is present. Suppose if you want the minor of Aij, the element Aij, it is got by deleting the ith row and jth column. Suppose if you are taking a 3 cross 3 determinant, the minor will be of the order 2 cross 2. Then you have understood, if the minors are multiplied by suitable signs, positive or negative, we get the cofactors. The formula is given by minus 1 power I plus j into mij. You know, minor of an element Aij is denoted by mij and the cofactor is denoted by Aij. And afterwards you have understood two important theorems or properties. That is, one, elements of any row when multiplied by the corresponding cofactors and added, its value is equal to determinant A. Then you have understood the second property. If the elements of any row or column are multiplied by corresponding cofactors of any other row or column and added, its value is said to be 0. And you have understood the problems, basically the problems how to find out the minors and cofactors of all elements of a 2 cross 2 matrix and also 3 cross 3 matrix. Let us solve 2 or 3 problems based on the properties which we have studied so far. Let us take up the problems. So it is given in the exercise 4.4, the third problem. It is given using the cofactors of elements of second row. Using the cofactors of the elements of second row, evaluate 538, 201 and 123. You need to find the value of this. But you are supposed to use the elements of second row. It is asked. Second row. Using second row, you have to find the value of the determinant. You know how to find the value of the determinant directly. But you are not supposed to do it directly. But you have to expand it using the cofactors of the second row. So, how to find out the value of the determinant? 2 into cofactor of 2 plus 0 into cofactor of 0 plus 1 into cofactor of 1. That means you are finding out A21, 0 into A22 plus 1 into A23. I think you have understood how to find out this. This is A21, this is A22 and A23. So let us find out A21. What will be the sign? Sign will be negative, and leave the row and column in which 2 is present. Leave the first column and second row. You will be getting 3, 8, 2, 3 plus 0 into A22. What is the sign? Sign is plus. Leave the second column and second row. You will be getting 5, 8, 1, 3 plus 1 into A23. So you want cofactor of 1. What is the sign? Sign is minus because 2 plus 3 is 5. Minus 1 power odd number is minus. So you leave the second row and third column. It is 5, 3, 1, 2. So you will be getting minus 2 into 3 3s are 9 and 8 2s are 16. You know how to evaluate this. 0 multiplied by 5 3s are 15 minus 8. Minus 1 into plus into minus 1 into 5 2s are 10. 10 minus 3. What is the answer you get? 2 into minus 7 plus 0 multiplied by anything 0 minus 1 into 3 you get. What you will be getting? 14 plus 0 minus 3. 14 minus 3, answer is 11. So, using the cofactors of the second row, if you find the value of this determinant, it will be 11. I think you have understood. 2 into cofactor of 2. It is got by deleting the first column and first row. 3823. 3823 value is 9 minus 16. You will be getting minus 7. Plus 0 into anything is 0. Then again 1 into cofactor of 1, 5, 3, 1, 2. 10 minus 3, it is equal to 7. As it is minus, it is 10 minus 3, it is equal to 7 now. 7 into 1 is 7. So you will be getting 14 minus 7, the answer is 7. So answer is 7 for this. I think you have understood how to solve this problem. 10 minus 3 will be 7. 14 minus 7 you will be getting, answer is 7. I think you have understood this problem. I take up the next one, fourth problem. Using the cofactors of the elements of third column, evaluate is given 1 x y z, 1 y z x, 1 z x y. You need to find out this. Using the cofactors of the third column. Third column you have to find out. So, yz into cofactor of yz plus zx into cofactor of zx plus xy into cofactor of xy. This is what requires. Yz into. This is nothing but A13 zx into, what is this? Zx is nothing but, it is A21, A22 and A23 plus xy into is nothing but A33. Yz into, see here the sign is positive, leave the row and column in which yz present, 1y, 1z plus zx into, what is the sign here? Sign is minus. A23, you want A1, if you leave the second row and third column, you will be getting 1x, 1z plus xy into A33, that is cofactor of xy. Leave the row and column in which xy is present, it is 1x, 1y. So what happens now? Yz into z minus y minus zx into z minus x plus xy into y minus x. So if you multiply this, yz squared minus y squared z minus z squared x plus zx squared plus xy squared minus x squared. This is what we get. This is the expansion of the determinant using the third column. I think you have understood. You need to find out the value of the determinant using the elements of third column. Now yz into cofactor, that is cofactor of, that is yz, and zx into cofactor of zx and xy into cofactor of xy. So we get the answer, this one. Let us take up one worked example here. Here it is given in the determinant 2 minus 3 5, 6 0 minus 4, sorry it is plus 4, and 1 5 minus 7. Verify that it is given, verify that A11 into A11, A12 into A12 plus A13 is given A31, and here it is A32, A13 into A33, that's equal to 0. You have to prove that. So I consider LHS A11 into A31, A12 into A32 plus A13 into A33. So what is A11? A11 is the first element, 2 into, what is A31? A31 means third row first column. You want cofactor of this, it is positive. Leave the row and column, we get minus 3 5 and 0 4. A12 is nothing but minus 3, and we have to multiply that with the A32, cofactor of A32, that means cofactor of 5. What is cofactor of 5? It is minus, leave the electron column, 2564. 2564. A13 is 5 into A33. A33 is cofactor of minus 7. Leave the electron column, you will be getting 2 minus 3, 6, 0. What you will be getting now? 2 into minus 12 minus 0. Minus 3 into minus of 2 4s are 8 minus 30 plus 5 into 0 minus of minus plus 18. Let us consider it's minus 24 minus into minus plus 3 into 8 minus 30 is minus 22 plus 5 into 18. So what is the answer? Minus 24 minus 66 plus 90. Minus 24 minus 66, it is minus 90 plus 90. What is minus 90 plus 90? 0. Hence we conclude this property. I have already told, if the elements of any row are multiplied with the cofactors of any other row and added, its value is definitely equal to 0. Today we have solved 3 problems on the properties of minors and cofactors. I think you have understood these 3 problems. If you have understood, we have come to the end of the exercise 4.4 now. Students, now comes the important topic called adjoint and inverse of a matrix. So please write the headline: adjoint and inverse of a matrix. Adjoint and inverse of a matrix. This is one of the important concepts, adjoint and inverse of a matrix. Please understand, let us start with the adjoint of a square matrix. Adjoint of a square matrix. This is the first concept. Topic name is adjoint and inverse of a matrix. In that we are going to discuss with adjoint of a square matrix. So let us understand what is the meaning of adjoint. Dear students, you can see that A is a matrix which is A11, A12, A13, A21, A22, A23. Then A31, A32, A33. We have considered a 3 cross 3 matrix, 3 cross 3 square matrix. It is a matrix of order 3, square matrix of order 3. And we have already taught you how to find out the cofactors. See, let us take cofactor of matrix A. CF means cofactor. What happens if you take the cofactor of the matrix? You will be getting A11, A12, A13, A21, A22, A23, A31, A32 and A33. I have taught you this in the previous class. Given a matrix, how to find out the cofactor of a matrix. For all the 9 elements you can find out the cofactors. Then comes the important concept, what is the meaning of adjoint of a matrix? Remember, adjoint of a matrix is denoted by ADJ of A. ADJ of A, and adjoint of a matrix A is got by taking transpose of matrix of cofactors. You have to take the transpose of the matrix of the cofactors. What happens if you take the transpose of the matrix? You take the transpose of this A11, A21, A31. Here A12, A22, A32. A13, A23, A33. Think you have understood how to take the transpose of the matrix of cofactors. Understand, students? Given a matrix A, cofactor of a matrix A, you know. If you take the transpose of the matrix of cofactors, you will be getting the adjoint. Then what do you mean by adjoint of a matrix A? Adjoint of a matrix A is defined as a matrix obtained by taking the transpose of the matrix of the cofactors. You are given the cofactor of matrix And when you take the transpose of the cofactor of a matrix, you will be getting the adjoint of the matrix A. Remember, adjoint is also called as adjugate of a square matrix. Remember, adjoint is also called as adjugate of a matrix A. Adjugate. Adjugate is the alternate word used for adjoint. Remember, adjoint of a matrix is also called as adjugate of a square matrix, and it is denoted by ADJ of A. ADJ of A. Let us take one simple example how to find out the adjoint of a matrix. Let us consider a simple matrix 1, 2, 3, 4, 2 cross 2, 2 cross 2. Let us understand how to find out the adjoint. Here the matrix A is given. You find the cofactor of each element. What is the cofactor of the first element? A11, that is the thing, but 4. What is A12? Cofactor of the second element, leave the row and column, and -3, because you know the rule of signs for 2 cross 2, plus minus, minus plus. You take A21. A21 means you want cofactor of 3. So sign is minus, leave the row and column, you will be getting 2. Now you take A22. What is that A22? A22 is second cofactor of 4 here. Second row, second column. Sign is positive since the sum is plus. Leave the row and column, you will be getting 1. Now we take cofactor of matrix A. What is cofactor of matrix A? 4, -3, -2, 1. This is what the cofactor of the square matrix. Now let us find out the adjoint of the square matrix. What do you mean by adjoint? Adjoint of a square matrix is defined as transpose of the matrix of the cofactors. So I get here 4, -2, -3, 1. This is the adjoint of a matrix. Please see here. A, I think you have understood. Let us find out the cofactor of each and every element. For the first element, the cofactor is 4. For 2, the cofactor is -3. For 3, cofactor is -2. For 4, cofactor is 1. You find the cofactor of a matrix which is given by 4, -3, -2, 1, and the adjoint is given by transpose of the matrix of cofactors 4, -2, -3, 1. See here, from A to adjoint A, let us understand how to find it out directly. Very simple here. So we can find out the adjoint of 2 cross 2 matrix directly by interchanging the diagonal elements. See here, 1, 4 is there, you write it as 4, 1. Interchange the diagonal elements and change the signs in between. See, 2 means you have to get -2, 3 means you have to get -3. If you interchange the diagonal elements and change the sign of the other elements, you can find out the adjoint of a 2 cross 2 matrix directly. This is the shortcut method to find out the adjoint of 2 cross 2. Remember how to get the adjoint of 2 cross 2 directly? It is very simple. It's very simple. Interchange the diagonal elements. You have 1, 4, make it 4, 1. And change the signs of the other elements. -2, -3. Remember, this shortcut method is applicable only for finding the adjoint of 2 cross 2 matrix, not for 3 cross 3, remember. So first you have to understand the meaning of adjoint of a square matrix. Adjoint of a square matrix is defined as a matrix, the transpose of the matrix of the cofactors. It is denoted by ADJ of A. And 2 cross 2 matrix, you can find the adjoint directly by interchanging the diagonal elements and changing the signs of the other elements. Students, I think you have understood how to find out the adjoint. Similarly, we can find out, if we are given a 3 cross 3 matrix, find out the cofactor of all the 9 elements, form the cofactor matrix and take the transpose of the matrix of the cofactors. Think that's the end of it. I think you have understood. Let us move on to the theorem, one of the important theorems. We have an important theorem that states that very important theorem it is to find out the inverse. Very important theorem. If A is a given matrix of order n, then always remember A into adjoint A is equal to adjoint A into A is always equal to determinant A into I. This is the important property we have. Suppose if you have adjoint then A into adjoint A is equal to adjoint A into A is equal to determinant A into I. This is what to prove. So I write here to prove that A into adjoint A is equal to adjoint A into A is equal to determinant A into I. This is what we have to prove. Okay? So you have understood how to find out the adjoint now. Let us prove it for 3 cross 3 itself. So what is the adjoint of a square matrix? Adjoint of a square matrix is got by taking the transpose of the matrix of cofactors. A11, A21, A31, A12, A22, A22 and A32, and then A13, A23 and A33. This is the matrix of transpose of the matrix of the cofactors. A11, A21, A31, A12, A22 and A32, and A13, A23 and A33. This is the adjoint. What we have to prove? We have to prove that A into adjoint A is equal to adjoint A into A is equal to determinant A into A. I take up LHS A into adjoint of A. What is A now? A is A11, A12, A13, A21, A22, A23, A31, A32, A33. What is the adjoint of the matrix A? Adjoint of the matrix A will be A11, A21, A31, A12, A22 and A32. Then A13, A23 and A33. This is what the adjoint is. Now it is simple matrix multiplication. Dear students, you have to be very careful now. How to multiply this? First row, first column, A11 into A11, A12 into A12 plus A13 into A13. That's what we get. First row, second column, you will be getting A11 into A21, A12 into A22 plus A13 into A23. Then first row, third column. First row, third column, A11 into A31, A12 into A31, A32 plus A13 into A32. That's what the first row into first column, all the columns. Let us take up second row. Second row, A21 into A11, A22 into A12 plus A23 into A13. Let us take second row, second column, A21 into A21, A22 into A22 plus A23 into A23. Let us take second row, third column. What is second row, third column? A21 into A31 plus A22 into A32 plus A23 into A33. Second row, all the columns are over. Let us take up the third row. Third row, what happens? A31 into A11, A32 into A12, A33 into A13. Second row, second column, A31 into A21, A32 into A22 plus A33 into A23. Let us take up third row, third column, A31 into A31 into A31 plus A32 into A32 plus A33 into A33. This is what we have got, and you complete that matrix. Now use the property. Use the property. What is that property? Elements of any row, when multiplied with the corresponding cofactors of the same row and added, its value is always equal to determinant A. This is equal to determinant A. What about this? Elements of any row, when multiplied with the corresponding cofactors of the any other row and added, its value is always 0. We are using second property. Again, here also it is equal to 0. Again, here also it is equal to 0. But here, elements of second row are multiplied with the corresponding cofactors of the second row. So its value should be equal to determinant A. This is 0. Again here it is 0. Again property 2 0. Here elements of third row multiplied with the corresponding cofactors of the third row itself. It is equal to determinant A. Now we can take determinant A as common factor. 1 0 0 0 1 0 0 0 1. So you will be getting determinant A into I. Similarly, I can prove adjoint A into A is equal to determinant A into I. Therefore, I conclude adjoint A into A is equal to A into adjoint A is always equal to determinant A into I. This is very important property. But we have proved this using the properties, two elements of any row with the corresponding cofactors of the same row and added means its value is determinant A. Here in diagonal we will be getting determinant A. So we take determinant A as common factor outside, then you get 1 0 0 0 1 0 0 0 1 determinant A into I it is. I think you have understood how to solve this problem. I move on to the next theorem now. Now, you have understood A into adjoint A is equal to adjoint A into A is equal to determinant A into I. Now, let us understand the two important definitions. One is the singular matrix. One is the singular matrix. You have to understand the definition of singular matrix. Remember students, a square matrix A is said to be singular if determinant A is equal to 0. Let us take a matrix 1, 2, 3, 6. This is the square matrix you have. You take the determinant value 1, 2, 3, 6. So what happens? 1 into 6 is 6, 3 2s are 6. Determinant A is equal to 0. Hence, such a matrix is called as a singular matrix. Then what do you mean by a singular matrix? A square matrix A is said to be singular if determinant A is equal to 0. That's what the meaning of a singular matrix. Similarly, you can take the example of 3 cross 3 also. We have one more definition called non-singular matrix. Non-singular matrix. You consider an example. See, as the name itself indicates, a square matrix A is said to be non-singular if determinant A is not equal to 0. Let us take example 1, 2, 3, 4. You take the value of the determinant, you get 1, 2, 3, 4. What happens now? 4 minus 6. That's equal to minus 2, which is not equal to 0. Hence, the square matrix 1, 2, 3, 4 is said to be non-singular. Understand the definition of singular and non-singular matrix. A matrix is said to be singular, that is a square matrix is said to be singular if determinant A is 0. If a square matrix is said to be non-singular if determinant A is not equal to 0. Very simple definition we have got. Think you have understood this singular matrix and non-singular matrix. Think you have understood this. Please write down the definition. A square matrix is said to be singular if determinant A is equal to 0. A square matrix is said to be non-singular if determinant A is not equal to 0. Think you have understood this? I take up the next one, next property. That is very simple property. If A and B are singular matrices, remember, suppose if you have a matrix A as a non-singular matrix, suppose a matrix B is also non-singular matrix, then also remember AB and BA are also non-singular. That is, determinant AB is not equal to 0 and determinant BA is also not equal to 0. You have to remember this definition. If A and B are non-singular matrices, then AB and BA are also non-singular matrices. Remember, A and B should be non-singular matrices of the same order. then AB and BA are also said to be the non-singular matrices of the same order. So today in this class we have understood how to solve problems on inverse, that is especially cofactors. Two properties very important. Elements of any row multiplied with the cofactors of the same row and added means its value is equal to determinant A. Elements of any row when multiplied with the corresponding cofactors of any other row added, then their sum is equal to 0. Then you have understood the definition of adjoint of a matrix. Given a square matrix A, the matrix obtained by taking the transpose of the matrix of cofactors is called as the adjoint of the matrix A. It is also called as adjugate of a matrix A. It is denoted by ADJA. I have given you the example of a 2 cross 2 matrix. The adjoint of a 2 cross 2 can be obtained easily by interchanging the diagonal elements and changing the signs of the other elements. Then you have understood the properties. A into adjoint A is equal to adjoint A into A is equal to determinant A into I. Then we have understood the definition of singular matrix. A square matrix A is said to be singular if determinant A is equal to 0. A square matrix A is said to be non-singular if determinant A is not equal to 0. We have told the last property. If A is a non-singular matrix, B is a non-singular matrix, then AB and BA are non-singular matrices of the same order. So we have discussed all these concepts in this class. That's all for the day. In the next class we are going to solve properties and problems on the inverse of a matrix. That's all. Thank you.